Hi, this is Cole from Printer, and this is the attempt to assemble all the parts that we've built over the last 4 videos for the Lautr3k 3D printer without belts. First part to get assembled before we can put all these parts together is this lead screw, which is start 10 or 25mm pitch on it. You find these on the build list on Open Builds, the Open Builds website. They come from Trinity Labs, and they're rather dear, but they should do the job very, very well. Anyway, okay, parts we need is obviously the lead screw itself with the nut in the middle, 2 1mm washers or spacers that come from the mini wheel kits, or if you've sourced them elsewhere as well. A coupling, a flexi coupling. You get these off of eBay or anywhere, a few quid. I'd advise not to skimp on these, and I'll also advise you, because I've been waiting for one of these, for 2 of these for over 2 months. So make sure you get these off your build list if you're attempting to build this build first. You know, what you need for these is 6.35mm one end, and they couple to a 5mm the other end, and also 605 ZZ bearings. I think I may have skimped on the quality of these, time will tell, but if I have, then I'll replace them. Okay, you need 2 of these for each. Okay, I was struggling getting these bearings on this end of the lead screw. If you struggle, a bit like myself, get yourself a little bit of Henry paper, get WD-40 or a little bit of oil, and then just give the end a bit of a scrape, make sure there's no rubbish on there, and just take it down a little bit. You don't need to go mental, just enough, and then what you'll find is the washer, you put a wheel washer on the end, and then your bearing will just push on. Still nice and tight, you know, but it just makes it easier. I don't know what the cause was about for it, but that seems to solve the problem, and now I can get my washers on and my bearings on, really nice and done. Okay, right, that's that part. And now obviously you take your flexi coupling and the 6.35mm end, want to slide it in there, and obviously take your Allen key and tighten up this end. Okay, there we go. Okay, now we've got the lead screw ready to go. I'm going to put that to one side for a second. Okay, now take your X carriage, place your T-nut actually in the slot where the back piece is, and then make sure it's right. And the bottom side, another T-nut, just slide it up now. Now take this part push it in so it's in that print, just slightly flush. Now take your M5 10mm bolt, slide the nut just underneath, put the bolt in and tighten. Trust me, this is the easiest way of doing it, because I have attempted 3 other ways and they're all too fiddly. This is the quickest and easiest way I've worked out how to do it. Now, where's my other T-nut one? Okay. Right. You can actually get, if actually the T-nuts fall out, like I have on this, you can actually get to the back of it by using the hole on this part of the build and actually slotting into the T-slot through the hole in this print. Okay, push it in with the Allen key, and so it's lined up, and then drop the 10mm bolt into it. Should find it and bite. Tight nice and firmly. You just want your V-slot to be kind of flush with this print side, so it's nice tight. Just tighten these up. Okay. Let that T-pole out of there. Well, that's that side done. Right, next step. You take the lead screw that you repaired earlier with the bearings and your coupling. Okay, now you place the lead screw in like this. Move this up a bit. You place the bearing part into this tube part of your printer. Push in. It's a bit stiff, but be patient. Okay, that's nice. That fits nice. Move the X carriage up just to hold it. Don't screw this part to it yet. Okay, so that's nice. Right. Now we'll take the motor end. And again, we have the fiddly T nuts to deal with. Right. Also, you're going to need 3 for this side, because later you're going to add an end stop to this later on in the build. You just need to make sure there's a T-slot there, so there's something to bolt to. Now we slide the T-slot for the end stop eventually at the top here, like so. I'm going to put 1 T there. Okay. It's going to be a bit fiddly. Obviously we want to put the other T nut this side. I'm not sure if it matters which way the T-nuts are facing. I'm keeping the smoother side facing outwards. Okay, now slot your stepper motor shaft into the coupling, and at the same time put the V-slot into your print. There's a square hole made for it. again, we're just trying to get it so we're flush ish with the print, which we're in. That is solid. Luckily the lead screw gives us a bit of indication of how far to go. Right, now take your T-nut, push it slightly under this print, and then you need another 10mm bolt to place into this part here and tighten. Like so. Turn it over like that. Move the other T-nut under. Another 10mm bolt. Place it in there. Tighten. Okay, now important part, tighten your coupling to the shaft. Of the stepper motor. That's tight. Okay, you've moved the X carriage to the bearing end, the M5 25mm long nuts, bolts, place a nylon M5 locking nut and tighten, but not with force, just tighten it. M5 25mm nut, a bolt, and then the nut. Okay, now by hand, just run it down to the stepper motor end. What we're doing, we're just testing to see if there's any snags or how stiff it is actually to get down to the other side. To me that seems fairly stiff, but I'm just going to check. No, that's pretty cool. Bear in mind I've never built one of these before, so I've got no reference to how easy this should be to slide from one side to the other. seems pretty good. I mean, we are fighting against the stepper motor, so it's pretty even throughout. The tension wise, I didn't come across no snags where I had to give it a bit more extra force, so I am going to assume that is pretty much okay. So that is the assembly of all the parts from the last 4 videos, and so far so good. Okay, now we've got to this point. We measure the inside of the bearing side to the stepper motor side, and I have 411 millimeters. Now on the build manual from the actual designer of this 3D printer, he asks for it to be 410.2 of a millimeter. I've just asked him if it has to be that 0.2 of a millimeter, and he said yes, because he is Swiss. So I'm carrying that as a joke. Well, I hope it is, because I'm English and we did it by mil out. So anyway, he says, to be no, all the joking aside, he says not to worry about it too much as long as the top and bottom z-axes are the same. So hopefully we will not have too much of a problem with that 1/8 of a mil out. So thank you all again. See ya.